Hello! Outside of some Python and Java I did in high school computer science classes, I do not have much programming experience. I want to change that, and what better way to do so than by learning a new programming language? Given its great influence on many of the programming languages of today, the language I have decided I will learn to program in is C. As to how I will learn C, I will try to make a video game and hopefully succeed in doing so. I have never actually completed making a video game outside of some really small projects from school, so I'm very curious to see how this turns out. C is a compiled language, so before I start programming in C, I'm going to need to install a compiler. A compiler is what takes code and turns it into instructions that the computer can understand. The C compiler I have heard the most about is GCC. To use this compiler on Windows, I have to install something called min-gw. To install this, I simply followed the min-gw installation guide on the Visual Studio Code website and had zero issues whatsoever. Or at least that's what I'm imagining happened, as I forgot to record myself installing the compiler. Anyways, now that I have a compiler, I'm actually able to start programming in C. In Java, the language I am the most familiar with, you are able to create a window with incredible ease. In C, this is not so simple. C's standard library does not have the ability to create windows. To do this, one has to call upon platform-dependent APIs. If I wanted to create a window in Windows, the operating system, I would have to use the Windows API. Or if I wanted to make a window in Linux, I would have to call upon the APIs for X11 or Wayland. Because 2026 is the year of the Linux desktop, or so I'm told, I want to make my game cross-platform. And given this is the result of a non-insignificant amount of time watching tutorials on how to make a window in Windows, I want to use a library that will do this cross-platform nonsense for me. And what better library than Standard Direct Media Layer? Downloading SDL, which is what us cool kids call Standard Direct Media Layer, was easy. I now want to be able to use the SDL library in VS Code. This took me nearly an hour to get working because I wanted to be able to use the library without putting it directly into my project or without having to use the full path names in the command line when I wanted to compile my game. I eventually found out how to do this, and now the actual game development can begin. To start with SDL, I created a message box and did not mess up in doing so. I then created a window which the live studio audience really enjoyed. This only works because I have an empty while loop keeping the program alive, so to make the program actually do something, I learned how to do event polling, which checks every loop for inputs and then will process them. With this, I polled for a quit event, which means that every loop the program checks if the X is pressed, and if it is, the program will stop running. In making this window, I also used a feature of C that isn't present when programming in higher level languages like Java and Python. That is, pointers. Pointers are values that correspond to addresses in memory. These are used in place of the data in memory itself because they are significantly smaller, making function calls that would otherwise use the data in memory much faster. You know what, let's give the people what they want. Reopen the window! Oh god, close it! Since a window is only as useful as its contents, I need to add a renderer. This renderer is what will allow me to draw to the window. After a little tinkering, I got this piece of abstract art to draw on the window. This rectangle exposed me to another feature of C that was new to me: structs. A struct, short for structure, holds multiple data values as opposed to a standard data type variable, like a variable of type int or char, holding only one piece of data. In the case of the rectangle, the struct holds the values for the rectangle's x and y coordinates as well as its width and height. Now that I have an idea on how to draw graphics, I need to accept user input. To do this, I polled for key press events for the WASD keys. I used these inputs to increase or decrease the rectangle's x or y coordinates a little depending on which key of WASD is pressed, but this was a little sluggish. Increasing the amount that I moved the rectangle by made the movement look a little bit more natural, but there is one glaring issue with how this program is currently running, and that is it is eating my CPU. I decided to start over and remake the game's foundation with a constant frame rate dictating the game loop rather than what was essentially just a while true loop with a bow. This rework started off on the wrong foot as I looked into the function SDL timer callback, which was not quite what I was looking for, and ended up wasting a good hour looking into what function pointers are. Realizing that this wasn't what I wanted, I did the reasonable thing and completely deleted everything in main.c again and decided that I should actually plan out what my project's organizational structure would look like. This idea I came up with for the structure saw me make a file for initializing the game, a file for the game's graphics, and a file for the game's audio. In the file where the main game loop occurs, I use SDL delay in order to have my program wait before starting the next loop, unlike how it would previously just loop every single moment it had. And now look at the CPU usage. Now that the game runs at a smooth 58.82352941118 FPS, I can reintroduce the rectangle that will represent the player. For the player's movement, I found that just adding or subtracting from the X or Y looked really bad, as if you pressed any of the directional keys, the rectangle would move, abruptly stop, and then continue moving. I'm assuming that this happens for the same reason that if you press and hold a key in a text field, it will only type that thing once, then wait a moment, and then spam it. This way of controlling the player movement also caused the most recent directional key press to take priority over all others. So needless to say, this needs fixing. To fix these movement issues, I made pressing a directional key down change a variable unique to that key, removing that halting that was previously seen, and I would then set said variable to 0, or in other words, stop movement in that direction, upon the release of the key, which also fixed the latest key press taking priority. Now that I have the most basic of player movement implemented, I decided that I should try making this into a platformer, because why not? To start this process off, I make a simple array of rectangles and remove the ability to move the player down the screen via pressing the S key. I then add gravity in the most simplistic way by adding a small bit to the player rectangle's Y movement every frame. Now that I am starting to make actual gameplay elements, I think that having some sort of idea for what I even want the game to be would be beneficial. While I was testing around with the gravity, I realized that I quite liked how jumping around the air felt. So my basic idea for the game was now a 2D platformer where you traverse up the screen by jumping both on the ground and in the air. Exhilarating, I know. Speaking of the ground, I then added ground collision detection as well as wall and ceiling collision detection. The way I went about this sees the game check if the player is on a specific side of an object, and if when movement is added, if the player collides with, intercepts, or passes through that side of the object. If such a collision, interception, or passing through the object occurs, the player is then placed on that side of the object. I made the collision detection this way to avoid the player being able to face through an object if the player was falling too fast or if a platform was too thin. While I was testing out my collision detection, I just so happened to shrink the game window and saw just how awkward the game looked. I should probably fix this. The solution I came up with for this is to use what I call virtual screen width and height. These are just two fixed values that represent an imaginary 1920 by 1080 screen, and every coordinate in the game is pegged to this virtual screen. Using SDL get window size and SDL set render scale, the game now shrinks or enlarges the graphics in such a way that they will be proportional to this virtual screen. This now makes the game look slightly less bad. I started to get repulsed by the black and purple color scheme the game had taken on during my collision tests, so I decided that I wanted something that was easier on the eyes. Nice. Satisfied with the new colors, I thought about how many jumps the player should have before having to touch the ground again, and landed on 3. I added more platforms to the game and thought that spawning them at random locations would be interesting. I quickly found out why this wouldn't be a good idea and changed them to only spawn at random X values. I now want the screen to scroll up when the player ascends. I'm sure that I could look up some sort of a tutorial on how to do this, but I'm going to be annoying and try to figure out everything on my own. The way I decided to do the screen scrolling effect was by increasing the Y values of all of the platforms as the player ascends. The first few attempts at doing this were shockingly bad. In addition to this screen scrolling, I wanted the platforms that went off of the screen to be placed above the screen with a new X value to give the illusion that there was a never-ending amount of platforms. I eventually got the screen scrolling to look passable. After toying around with the distances between the platforms, I got them to a spacing that I was okay with, and noticed an issue. The first platform past the one that the player spawns on seemingly doesn't spawn in all that random of a location. To fix this, I found that by calling SDL rand before I generate the X coordinate of the first randomly placed platform, that said platform spawns at an apparently random location. I have no clue why this worked, but I'm not going to complain. Now that I have something that kind of resembles a game if you squint hard enough, I want to add a menu. I found that SDL is not able to deal with fonts on its own, so I downloaded the SDL TTF library. Having already gone through downloading SDL itself, this did not take nearly as long to do. I then wanted to find a font that was free to use and found this font. And after just a little while, I managed to make text appear in the game. Because I believed that making the game title would be rather trivial, I decided the first part of the menu I would work on would be the buttons. My idea is to have 3 buttons on the main menu, these being the level select button, the endless mode button, and the exit game button. For these, I made a button struct, which contains the button's text, the rectangle that will be the button itself, and a boolean that tracks if the button has been selected or not. Then, in SDL poll events, I poll for a mouse motion event, and when such an event occurs, a loop goes through every single button in the menu and sets its select status boolean to false if the mouse is not over it, or to true if the mouse is over it. I noticed that although this worked fairly well in full screen, it was a buggy mess when the window was shrunk. I fixed this by keeping track of the scale factors of this screen and scaled the buttons' positions by them when I compared the positions of the buttons to that of the mouse. Now with the buttons created, I believe that it has come time to name my game, and I present to you Jumping Square.
Yay!
Very creative, I know. Now that I have a main menu, it would be nice if the buttons actually did anything. I made the endless mode button send the user to the gameplay that currently exists, as it is already designed to go on forever, and I made the exit game button exit the program in the same way that pressing the X on the window would. My next goal when it comes to the menus is to add a pause menu. I want this pause menu to show the last frame of gameplay in the background and have buttons for retrying and returning to the main menu over top. This took a few tries, but it eventually worked out. Now that I have functioning menus, I want to add a score counter to the top of the screen for endless mode. Adding this in was actually really easy, and the only difficulty I faced was in centering the score label. Once I got this figured out, I also centered the text on the menu buttons. I also made the title blob in place just to give the title screen a little bit more character. At this point, I figured that the game needed some sound. I quickly made a jump sound effect and some music, and began trying to figure out how to actually have them play in-game. SDL allows for easy wave playback by default, so I do not have to download a separate library for this like I did for fonts. Even though there were no installation-related struggles, I still did struggle with this for a while, both due to me not knowing how the audio-related functions worked, as well as me messing up with the necessary pointers. But when it worked out, I heard the majestic sound that is theme.wave. I then began to work on a death menu and a level select menu. The death menu pops up when you fall below the bottom of the screen, and the level select menu will pop up when the play button is clicked on the main menu. If I'm going to make this into a level-based game, I am going to need a lot more content than just triple jumps and stationary platforms. This content will take the form of related structs that I call objects. I decided that all these objects in the game should be treated similarly when it came to drawing them to the screen and detecting collisions, so I created an object union that has a byte value for the type, that is player wall, platform, etc., and a struct for each corresponding object type. In total, I made structs for 7 different objects. In addition to more content in the levels, having levels will require me to make levels, and because I don't feel like having massive arrays baked into my game, I want to make a level editor that creates level data files that can be read by my game. And this won't be your average level editor. It will be worse. My idea for the level editor is I will put a series of numbers into a text file corresponding to this blueprint of sorts, and the level editor program will turn it into the same series of numbers, but in a non-human readable format. In the text files, I will also allow for comments by using brackets to make the file a little bit less confusing. Making the program convert the ASCII numbers into unsigned integers of the same value was fairly easy. Because I had the idea for the data file already planned out, creating the code for adding the data in the specific way I want was quite easy as well, and I just had to write the code equivalent to the blueprint. Before I start on writing the code that will read the level editor created data, I want to remake endless mode. By changing the player and platforms to objects instead of just rectangles as they originally were, endless mode no longer works. I use the same function for loading the objects for endless mode as I do for loading objects from level files, because even though there is no file to read for endless, I consider endless to be level 0. For endless, I allocate enough memory for 12 objects, and initialize all the default values the objects will have. Once I finished with this, I moved on to redoing collision detection. There isn't much more to say about this, so let's move on to changing the graphics to include all objects. Oh, this is quite boring too. Well, now that those are done, let's see endless mode. Oh, let's see what the problem is here. Oh, how silly of me.
Let me just search and replace that.
That didn't seem to do it. Well, time to spend 5 hours on this. Oh, that looks odd. Let me try changing that. That worked! So I made a bit of an oopsie there. When I searched and replaced my object-related dereferencing mistake, I forgot about the one thing I dereferenced without using the variable I. This caused the game to crash at first upon clicking the endless mode button, as you've seen, and later upon pressing pause. Or at least that's what I'm assuming, because in the footage, the moment I pressed pause, you can just feel my frustration emanating from the video. Well, with that roadblock out of the way, where were we? Alright, I was changing the graphics to include all objects. Since the player, platforms, and walls somehow all drew to the screen without issue, it is time for me to start adding the other objects. The first ones I will add are the spike trap, the barrier, and the enemy, or in other words, everything except for the exits because there will be no exits in endless mode. My idea for the spikes is that they will protrude from the walls and then retract back into them on a cycle. My idea for the barriers is that they will be an obstacle that the player must jump around, but they can't get too close without risking dying to its spikes. The enemies will be similar to spikes except they move along the y-axis instead of the x-axis. To make these shapes, I'm going to have to use something other than rectangles, and that something will take the form of an array of vertices. These didn't seem too complicated, so let's see how the spike trap turned out. Oh dear. Well, surely the barrier is better. Oh, it actually is. That's surprising. How about the enemies? Oh, that's just not even a hexagon in the slightest. It was these not-so-hexagonal enemies that made me realize that the vertices don't just connect one after the other and fill in with color the area, but every 3 vertices fills in its own triangle. Once I fixed this, the enemies finally looked like hexagons. Getting the enemies to move on a cycle was also pretty easy. The same cannot be said, however, about the spike traps. I couldn't just reuse the enemy code because the spikes would just enter the walls. I eventually got this figured out, and now it is time for hitboxes. Outside of the right side spike traps having a misplaced hitbox, getting the basic hitbox collision detection to work was fairly trivial. However, when it came to the collisions that should kill the player, there were some issues. Because these killing hitboxes could move, my preemptive collision detection no longer worked. I fixed this by adding checks to see if the player's hitbox was currently overlapping the killing hitboxes and killing the player if such an overlap occurred. I then made it so that these new objects will be reused in the same way platforms are once they are beneath the bottom of the screen. This worked pretty well, for the most part. Now with endless out of the way, it is time to make the level data reading code. This was actually easier than the level writing code because I didn't have to make code that converted ASCII to the actual integer values. What this means is that SDL's integer reading functions really did all the work for me. I then made a quick level to test my level reading code and to serve as the game's first level. This didn't work at first because I had forgotten to give anything read from data a type, causing the rest of my code to not understand what the data was. I fixed this and it worked. I finished making the shape for the exit and now we have a full level. I also made it so the screen would stop scrolling once the players made it to the exit to signify the level's end. Speaking of the exit, I made it so colliding with the exit would start a loading screen animation and load the next level. My first few attempts at this were utter failures, but I eventually got it to look somewhat okay. Now that level transitions work, I began to work on more levels. With these new levels came the need for me to implement moving platforms. My first go at this didn't work, but my second one did. Well, maybe not worked, but it looked better. After a few attempts at fixing this, I got them into a state that I deemed sufficient enough for the time being, and began working on more levels. This level introduced the last kind of platforms, shrinking platforms. This was fairly easy to make, but I had some small troubles when it came to platforms that both shrank and moved. I thought it looked awkward having only one side seemingly shrink, so I ended up just making these platforms that both shrink and move halt their sideways movement once they began shrinking. Now that I have every object made, it is time to make the rest of the levels. Sorry, let me play some hype music. Oh yeah, that's more like it. Oh come on, what's the problem now? It turns out I had forgotten to initialize this boolean, which caused my program to think I was in a comment when I really wasn't. This luckily didn't take as much time to fix as the search and replace disaster from earlier. After this ordeal, I went back to making levels. I also changed the hitboxes for the enemies and the barrier spikes to be more forgiving, and I fixed the moving platforms pushing the player into the walls by making them bounce off of the player. This same bouncing behavior also occurs when the platform would have otherwise pushed the player into a barrier. Given I made it an option to change the character size in the level text files, I decided to play around with the player's size in the last few levels. I also thought that I should make a very vague story to go along with it so the size changes aren't just completely random. To do this, I decided to make one more object that I call hints. These are just text that will exist within the level, meaning that they will move down the screen with all the other objects. I changed my level editor to check for hints after it is checked for exits, so I don't have to bake these hint strings into the game itself, and so people can, if people for some reason want to, mod the game and add their own hints using the mod feature that I added. I added hints to every level that I thought needed them, those being the early levels to teach the player how to play, levels that introduce new mechanics, and in some secret areas. I also made some new music so it wouldn't just be the same song on loop. With this, my game was now complete. C was a fun language to learn. Most of its syntax was like Java's, so a lot of the main features like loops, conditionals, variables, and functions were things I already knew how to write. The features of C that I wasn't familiar with before, like pointers, structs, and unions, were fairly easy for me to understand, but some slightly more complex things like double pointers had me confused for a little while. Through learning about pointers, I became more acquainted with how memory works in computers. I also learned about the importance of being careful with search and replace and initializing variables due to my many hours spent fixing the results of me not being careful with them. I've put the source code for the game and level editor onto my GitHub linked below, so you all can look through this monstrosity yourselves. If you guys have any feedback you want to throw my way, may it be for how I programmed the game or how I edited my video, feel free to do so. If somehow more than 10 people watch this, you can throw me a suggestion for what I should do in future videos, and maybe I'll listen. Now, what is it that YouTubers do at the end of their videos? Oh right, subscribe and like!